Welcome to today's deep dive. Behind the walls of every perfectly minimalist wireless smart room, there is usually a terrifying rat's nest of cables.
Oh, absolutely. It is
Oh,
usually a complete nightmare.
right. But today we are looking at a spec sheet from HDTVSupply for a $490 device that is quietly fixing all of that. Our mission here is to decode the specs for the QSC QIO-GP8x8 Network 8 Logic I/O expander. It's a tiny 1.18-pound box that is completely revolutionizing how complex AV systems are actually built.
Yeah, and I know I/O expander sounds like pure engineering jargon, but it is actually the specific reason those modern sports bars and corporate boardrooms don't look like an exploded sci-fi prop.
Right, because we're finally moving away from running miles of individual wire.
Exactly. We're leaving that era of running a separate wire from every single physical room all the way back to some giant central control closet.
Okay, let's unpack this a bit. So the QIO-GP8x8 has 8 logic inputs and 8 logic outputs. And when we say logic, we're talking about the absolute simplest form of communication, right? Like basic on and off electrical signals.
Yeah, precisely. Things like a physical push button being opened or closed, or maybe a room occupancy sensor triggering when you walk in.
Right. And then the outputs just handle the reverse, sending basic voltage to turn on an LED indicator or trigger a buzzer.
Yep. But what's fascinating here is how it actually processes those signals. We're looking at a massive shift from centralized processing to a distributed architecture. Think of it less like a desktop computer where everything plugs into the back of a tower, and more like a biological nervous system.
Oh, I like that analogy. So the central processing hardware, like those newer units, the Core Nano or the Core 8 Flex, those act as the brain hidden away in a rack somewhere.
Exactly. And the standard network cables running through the walls, those are your spinal cord.
Meaning the QIO GP8x8 is basically the nerve ending, just sitting right at your fingertip in the actual room.
Right? It physically translates that analog electrical pulse, like someone pressing a real physical button, into digital network data packets that the brain across the building can actually understand.
Which completely decouples the physical input from the computing power. I mean, if you have ever tried wiring a boardroom and had to pull 30 thick specialized cables through drywall, you immediately see the appeal here.
Oh, it is a huge relief. You just run a standard network cable to the room, and this box handles all the local physical connections.
But wait, here's where it gets really interesting, or maybe a bit confusing. Because moving all those physical ports away from the main brain creates a new problem. How do you power these remote nerve endings without just creating, a new mess of power cords?
Well, normally you use power over Ethernet, or PoE. One single network cable carries both your data and your power.
Right, the spec sheet definitely mentions PoE. But reading further down into the daisy chaining specs, there's a catch. It says if you link 4 of these QIO devices together to save network ports, you actually lose that PoE capability.
Yeah, that is a really important detail to catch.
Because suddenly you have to buy a separate external power supply, the QIO PSU, I think it's called, to chain local DC power. Doesn't that defeat the whole purpose of cable simplicity? Like taking 1 step forward and 2 steps back.
It definitely looks like a step backward at first glance.
Yeah.
This raises an important question about system design, but it is actually a very calculated architectural trade-off.
Oh, really? How so?
Well, you are sacrificing the convenience of PoE, sure, but you do it to maximize your network infrastructure. By daisy chaining, you gain the ability to link 32 inputs and 32 outputs across 4 separate units. And all of that funnels back on just 1 gigabit LAN connection.
Ah, I see. So you're basically trading physical cable pulls for network bandwidth.
That is the key right there. You get massive scalability. Let's say a year from now, the client wants to add more occupancy sensors, automated shays, maybe some extra desk buttons. You don't have to rip open the walls to pull a second or third network cable back to the IT closet.
Wow, right. You just add another node to the chain on local power.
Exactly. You let that single gigabit connection handle the data load. It saves so much time and money on future upgrades.
So ultimately, this tiny quarter rank width device really proves that the future of AV isn't about building bigger, bulkier central hubs anymore.
No, not at all. It is all about these decentralized, easily scalable network nodes that translate the physical world into the digital one right at the source.
It's just wild. It fundamentally changes how our buildings operate, pushing physical interactions out to the absolute edge of the network.
It really does. It is a completely different way of thinking about physical space.
Which leaves you, the listener, with something pretty interesting to ponder as we wrap up today's deep dive. If basic physical interactions, like a room's occupancy sensor turning on the lights or a simple physical push button on a desk, are now entirely reliant on a cloud manageable IT network to function well, what happens to the magic of our physical spaces when the network goes down?